That's what the formula says. Once I get those, I can then add them up and be done with it. So what goes here? 6.83? 2. Here.
1.32.
Here.
2.10.
Here.
2.08.
Real quick, I know you guys have already done this shit. Can you see the mean is definitely not going to be here? What's going to pull the mean towards it? What's the heaviest weighted thing? 11 is. So the mean should be lower than it normally would have if I just had these 4 numbers. Because 62% of my data is 11. So the mean is going to be smaller than it would have been if it was just these numbers. You guys see that? Whatever's the heaviest thing is going to pull it towards it. It's like gravity. So what do you when you add these together?
12.32.
12.32. There you go. So it was pulled up. What's the average of 11, 12, 15, 16? 7 point. I forgot now. Shit. 7 point. 6 or something. I'm sorry. 7. What am I saying? I lost track of everything. What is it? Should be about 12, 15, so it's going to be 13.5. Thank you. So 13.5 is what it would have been if these were just the data points. Since I have a ton of 11s, the actual average came out a decent amount smaller than that. I like it. Okay, that's enough of that. Kick ass. So what did we just do? This is the sum of xp of x, because that's where it came from. It came from adding up these. So of course this is the mean. Kick ass. So what else do I want to figure out? What's the other most important number I can figure out from a set of data? Standard deviation. I like it. All right, this is going to take a little bit. We're gonna start with what will hopefully make sense. And then, of course, Jeff is going to actually make it easier. It's just not going to look like it's easier. So I'm going to see if I can get you guys to believe me. Now watch this. See how I took the values and I multiplied by their weights? Because the heaviest weighted thing should influence the mean more. So that would be true about anything I try to calculate. I'm going to have to multiply it by the weight. So let me do this here. To figure out the standard deviation of a set of data, I would normally do this, square it, and then go from there, right? Does that sound familiar?
Yeah.
I like it. So what I'm going to do then is, since I actually have probability of x's involved, I have to take this and multiply by the probability of x. I got to multiply by the weight. So what do we used to do? We used to add these up and then divide by how many there are. Now I have to multiply by the weight first and then add them up. And somebody remember, I don't have to divide by n. Why? What's on the bottom of this already? Any probability has what on the bottom? N. So it's built in. So here, I would have added those up and divided by n. Maybe? Yes, remember? And that would have been the variance. But now I would just have to add these up. Because there's already an over n here in the probability. Are you guys semi with me? So I know this has to be a part of the standard deviation calculation because this is the idea of standard deviation. How far away is every data point from the mean? I have to multiply by the weight for reasons we already discussed. And then it's already got the over n built in. All right. So you could do it this way. I really have no problem if you do it this way. There's a slightly better formula to use. And I'm going to show you the first few steps of where that formula comes from. And the very first step involves me turning the camera. There you go. So let me blah, 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 blah. So the sum of these, that would be the variance. Now, put your algebra brains back in. If I gave you this in algebra, what do you think I would ask you to do with it? To simplify it. No, it's not in an equation. I can't square root something out of nowhere. If I had an equation, I could square root both sides, because then I have balance. See? Foil. I like it. Even though I hate that we invented foil. I'm not going to go into that. Well, I have to say something, because some of you guys might. Remember foil? Everybody remember foil? Yeah. The reason I personally hate foil is because if you make a mnemonic device, it sounds like it's really hard to do unless you have that mnemonic device. That's what mnemonic devices are for. Mm-hmm. Foil is just repeated distribution. I don't need no frickin' foil. But anyway, I'll get over it. Sorry. Come back. So how do I foil this out? Let's kind of focus on just that piece. So if I have just this piece, let me just pull that out, pull the heart out, put her in there. How do you get that reference? How do you get that foil started? Yes, square means multiply it by itself. Of course you can't do this. No, stop that shit. Now do it. Just take a minute and do that. Go ahead. Distribute that out. Or foil it out, whatever you prefer. Just by the way, we've done this a few times, but we are in the middle of deriving a formula right now. You're not going to suddenly have to know all this stuff to do yourself. I'm trying to derive a formula that's equivalent to this, that's somehow easier to use. So what do you guys get?
X squared minus 2x plus mu squared.
Kick ass. So let me put that back in. Let me put this up here. So the variance is the sum of x squared minus 2 mu x plus mu squared times p of x. All right, how are we doing so far? I was told there wasn't much algebra. Be quiet. We're only going to do one more step. And because this isn't summation algebra class, I'm not going to show you every single step. You're going to have to go a little bit on faith here. And if you don't trust me, then I'm going to say do it yourself, and then I can help you with it. So here's the step I'm going to focus on. What do I do with this? Is this times that. Distribute. So what would be the first thing I would get? The sum of p of x. Does everybody see that? And then, here's the magic part. It's not magic, it's just steps I'm not showing you. Everything else becomes this. If you don't believe me, you can do it yourself. If you don't want to do it yourself and you don't believe me, you can come to my office. I'll show you the steps. But I at least want you to buy in that this looks feasible, because the first piece, you can actually see where it came from. The rest of it, a little bit gross, but not too bad. Some of you guys, a couple of you guys might be interested in trying to do that yourself. Okay. Or you're like, dude, I'll take your word for it. So why is that? I'm suggesting that this is a better equation than this. And it really doesn't matter which one you use, but watch. What do I already have here? X p of x. What column do I need according to that equation? What am I going to add up? Cover the E. I need to add up these. See that? So I need a column of x squared p of x's. Is everybody with me? How did I figure out to make this? Because the mean formula needed the sum of those. So I need to make those first. What does this need? The sum of those. So I need to make those so I can add them up. That's how every equation works, with an E in it, a summation symbol. A sigma is what it really is, but oh. You can cover it, see what you need, make them, and then add them up. It kicks so much ass if you let it. So I just need a column now. This is the column I'm going to add for the variance. I need a column of x squared p of x's. You can always read your mind. You're like, does this ever not be weird? So part of this, again, I always want to say this in every math class I teach. You have an idea you start with. You write the math out. And then the rules of algebra and more advanced math sometimes helps you kind of simplify that thing you're working with. It never changes the idea you started with. You're just doing some math manipulation. So can I see the idea in this equation? Oh shit, no. Can I see it in this equation? Yeah. The distance between the data points and the mean. I can see the idea. Here I did some math shit. Idea is lost, but algebra guarantees these are the same equation. So to do this, here's what I do. I do L1 times L3 because I'm crazy. Because what's x times x p of x? X squared p of x. Why don't you just square this column? Because I'm squaring x and p of x then. It's not what it wants, is it? You guys see that? So be really careful. Don't think you got a shortcut. So what is 11 times 6.82? 75.02. And then 12 times 1.32.
It's 15.84.
And then 15 times 2.1.
31.5.
And 16 times 2.08.
33.28.
Thank you. And then if I add those up, I've got that first piece of the equation. Do you see that? Somebody save me from myself.
155.
What?
155.64.
I was not gonna stop to tell you. So we know the mean. The mean is 12.32, right? We did that earlier. Now I've got this, which is the sum of x squared p of x. So anywhere I see this, I can replace it with that number. I already see it over there. So let me see. The variance will be 155.64 minus that squared. The biggest mistake people make is they forget to square the poor mean. It's not fair because these guys are squared. You should be squared too.
Okay, so where did you put that at again?
Which one?
You said you replaced it? Yeah.
So this was the sum of these.
Okay.
And where do I see the symbol? Right there.
Right there.
So what did I put in its place? What it is.
Got you.
So in statistics, I don't just replace single letters with values. I replace entire phrases, like these little expressions with values. I know what this whole damn thing is. So I replace that whole damn thing with what it is. What do you guys get for the variance there?
3.8576.
That's the variance, right? Yeah, that sounds about right. Yeah. Right? Is it? Sounds maybe. Sure. Really? Maybe. And then if you square root that, you get the actual standard deviation.
So did you subtract that, those two?
Yeah, let me do it up on the overhead. Let me do it in the calculator on the overhead. And I'll show you how to do the lists and all that too. Come here. So see what it looks like in the calculator. Anybody want to borrow a calculator? You're gonna need. Oh, I'm sorry. I got my own little table. It's all good. I tried to set this up so I didn't have to mess with you guys too much. Anybody need a calculator?
I do.
Calculator. Everybody else is alright? And not surprisingly, I have a handout with an example of this work down on one side. On the other side, you're going to do a problem here in a bit. This is like the ad at the beginning of a video. Come on. Where's the skip button? There we go. All right, so how do I put this in my calculator? I go to Stat, Edit, of course. Let me clear some of this stuff out. Clear, clear, clear. You don't have to actually say it every time, do you? All right, let me give you guys a second. Catch up to me. Nice clear lists. All my lists are there. If ever something freaky happens to your list, hit Stat number 5. Setup Editor. Enter. It'll bring it back to normal. So let's put this data in. What do I got here? I got 11, 12, 15, 16. And kick ass. So then I want L3 to be what? Yeah, I want an x p of x, so L1 is the x's, L2 is the p of x's, so L3 is L1 times L2. Highlight L3, make sure you're telling it what to make that whole list. L1 times L2, just like that. And I should get the same numbers. Oh, thank God. Right, is that cool so far?
Yes.
And then what do I want L4 to be? You can do it two different ways, really. I do L1 times L3. You could do L1 squared times L2. Do you guys see that? Either way is going to come out to be the same numbers. Math don't care what order you do those in. It's all multiplication. So I'm going to do L1 times L3 and hope that I get the same numbers we got. Yay. Coolness. So again, you don't have to do this. We did this without doing it in this fine. It's just a little quicker, especially if the list gets long. And then how we get sum up the L4 and the L3 for that matter. Let me see if you guys can handle this. Where do I have to go? Where have I told you to go to add up a list? List, calc, sum, bullshit. All right, you can do that again. So I can go to list, math, sum of L3, and there's my mean, right? Is that cool? Now watch. And you can do that with L4. No big deal. But just to show you, if you do stat, calc, two variable stats, and I do it on L3 and L4, let me see if anybody can handle this. See how see how x's is assuming the x's are in L3 and it's assuming y's are in L4. The only thing I care about in all this shit is the sums. Look, sum of x is 12.32. Sum of y is 155.64. Do you have to do it this way? No, you can do the stat, the list, the blah, the math, blah, sum. Yeah, that's fine. Just in case something, it's a little tiny shortcut. I like it. And then I could do my 155.64 minus 12.32 squared. Was that it? Yes. And that's where we got 3.8576. And then square root of that, and that's where we get 1.964. That's the standard deviation. And real quick, just look. That's about 2, right? How far away from the middle do all the numbers seem to get on average? 2 looks to be a decent, so if you got a standard deviation of 12 for this data, that doesn't make any damn sense. They're not 12 away from the center on average. Do you see that? So once you get to a point where you can at least tell the standard deviation makes sense. 2 makes sense. They're not very spread out, but they're not like right on top of each other, so 2 makes sense. Okay, maybe. All right, and then here's the ultimate thing before I give you this handout. Of course, calculator costs a lot of money. It's got to have a way to do all this shit itself, and it does. Somebody help me out. Where's the data in this table? Which lists or lists? L1 and L2. Together, this is the full data set. If I just tell you these, it's not telling you that there's a lot more 11s. So together, this is my data. How many variables are up here? Don't think about what I just did. How many variables are in this table? Now, how many values? How many variables? 1. X. So if now watch, this is where things get a little weird. And again, you don't have to do what I'm about to do, but if you go to stat, calc, 1 variable stats, but now I'm going to have to tell it, my list is L1, that's where my data is, that's where my data values are, but my frequency list is L2. So I got to tell it it's an L1 and L2. Let's see what it tells me. And it looks familiar. Everything looks familiar. Yay. Right? So this is how I can check your work. Right? Okay, so let me give you this sheet we're going to work on. Then we'll see what time it is. Here it is. So one side is a fully worked out problem. The other side is what I want you to work on.